Hello, in this video we are going to look at how to sketch parametric curves and change them from parametric to rectangular, and also look at one application of parametric equations. I have 4 questions. My first question I have up on the screen I have already moved over so that we can go through this process together, and we can see that I got x equals 6t plus 5, y is equal to t plus 2, and we're looking from t from being 0 to 4 inclusive. What a parametric equation does is set up a formula, if you will, to find the x and the y part of the coordinate. It introduces a third variable into the mix, and that is t for time. You can sketch these by hand pretty easily, although we're going to look at how to do this in the calculator. We're looking from t being from 0 to 4, and so what we'll do is, if I wanted to find out what this looked like, I would start out, well, when t is 0, and I plug it into here, I would get out x being a 5. And if I plug 0 into the y, I would get a 2. And so my first point that I would sketch is 5, 2. That is when t is equal to 0. And I would just slowly work my way up to 4. If I plug in a 1, I get out an 11 and a 3. If I plug in a 4, I get a 29 and a 6. And so I would have those 3 points. If you needed more or less, you can work through there. Let's look at how to do this on the calculator. When I turn on my calculator, I'm going to go into Mode, go down to where it says Function, and then I'm going to scoot this over one place to the left, to the right where it says Par, and that is for parametric, and hit Enter, so now that's highlighted. When I hit y equals now, I'm not going to have just y equals. I'm going to have an x equals and a y equals, and I can type in my functions. Now you could go ahead and hit graph as is, or you can also go into your window and change your min and max. And you can change what the step looks like if you only wanted to see, like, plug in integers, go by half, go by wherever you want to go by. Now when I hit graph, I'll see most of it. Since I have some pretty big numbers here, let's see if I can do zoom fit and get a little bit of a better picture. Now it comes up really fast, right? If you go back to y equals and go out to the side, and you see how now it's moving a little bit, and hit enter twice so that you see this little bubble at the end. Now when you hit graph, it's going to show the direction, because parametrics don't just make the graph, they also have a specific direction. So anything that from my answer choices that shows my arrow going down is out, because my graph went up like this from left to right. It also didn't have any negatives because we didn't have any time in the negatives. So this must be my graph right here. Now sometimes the graph kind of keeps going, even though you set a t max. So you just have to kind of make sure that you're paying attention to what you actually want sketched. I'm going to go back over to MyLabs Plus and select C, so that we can see what the next part of this question is, and that is to talk about what is the rectangular equation of this curve. If you didn't want to talk about x and y separately, and you just wanted regular f of x, what would you do? Well, if x is equal to a 6t plus 5, I can subtract a 5 and divide by the 6 so that I get t is equal to x minus 5 all over 6. And if that's the case, I can take what t is equal to and kick this t out and put this in instead, so that the rectangular form of this would be x minus 5 over 6 plus 2. You can clean it up or not cleaning up, but you know, if you want to find a common denominator and say that this is 12 over 6 and add that in, you could do that. You can separate the 1/6 x minus a 5/6 plus a 2t. How do they want it written? Sometimes you have to play with it a little bit. Sometimes they also ask, well, they gave us a restricted domain based upon t. Well, now what is it in terms of x. If t goes from 0 to 4, all I would need to do is talk about, well, now I'm talking about x's. If t was 0 from 5, and when it was a 4 to a 29, so that I can just swap those in. So that way I'm not talking about t anymore, right? Because I don't have a t to plug in anything over here, right? And I would have to plug in for x. That's it. That's how you deal with parametrics. Here's another one. I have x equal to a t squared plus 1, and y is a t squared minus 5. Now we're going from negative infinity to positive infinity, and I want to look at what this graph looks like. Sometimes when they go to infinity, they can be a little bit of a pain to sketch, so I'm just going to go right to the calculator. I got t squared plus 1. I got a t squared minus 5. I don't really need to talk about from infinity to infinity, and I'm going to look at these graphs a little bit. It looks like my step I can leave a 1, and I'm going to go negative 10 to, let's say, 20 for a max. And for the y min, I'll go negative 10 to 10, because that's what I basically have on these over here. If you didn't have something to look at to see where your mins are going to and from, then you might want to just go ahead and hit graph and move around the screen as you need. I'm going to hit graph. Oh, it went pretty quickly. Maybe zoom fit. And it looks like we're just going straight up. Certainly doesn't look like this one or that one. No curve. So it looks like this, but we never saw it come back. But that's maybe a part of the graph that's too far out. Let's see if I can zoom out, and I'll zoom out right about there. You can see, oop, I think it real quick came back. So it looks like we're going to go with C. And let's look at what this equation looks like. All right, well, let's see. I got x equal to a t squared plus 1. So I got x minus 1 is equal to a t squared. It doesn't have to be x equal to t, right? I got a t squared there, so I'm going to take that t squared out and put x minus 1 in. And that's why it doesn't have a curve. It's just x minus 6. One more that is a little more straightforward. I got x equal to 2 cos t and y equal to a 5 sine t. Now notice these have different coefficients, so we're certainly not going to be talking about a circle. If I have different coefficients, then we're talking about an ellipse. I'm going from 0 to pi, so we may not be going around the whole graph, something like this. And I have my calculator to do some of the heavy lifting for me. I'm going to make sure I'm in radian and put in 2 cos t and get that little extra 1 out of there. 5 sine t. I'm going to change my window from 0 to a pi. Well, then I'll leave it as a, well, maybe I won't do that. I'm going to just say pi. Step of a 1 may be a little too big, so let's just say 0.1. And it looks like we're going from a negative 10 to a 10. Let's hit graph. Oh, this one's moving nice and slowly so we can see what's happening. And that pretty clearly looks like B. Now, if you're ever asked on an assignment to sketch a parametric equation, and you just do something like this, you are probably not going to get full credit. Parametrics must have the arrow, or else you don't know which direction you're going. So let's look at this question. Uh-oh, looks like we maybe got moved around a little bit. There we are. And let's find the parametric, the rectangular version of this. So this is going to look a little different. I know that cosine squared plus sine squared is equal to 1, right? That's our big Pythagorean theorem. trig identity that we use a lot. Well, I don't quite have cos squared or sine squared, but if I say divide by 2, I get x over 2 is equal to cos. And if I say divide by 5, I have sine is equal to y over 5. So now I can just go ahead and square it. And I got x squared over 4 plus y squared over 25. And that's equal to 1. And that is the equation of my ellipse. And so now I can come back over to here and pick the right one, hopefully. There we go. And then we're all finished with that question. So don't be scared of the trig ones. Now for the big one. The very last question is our baseball question. And it's a little sneaky. I got a baseball player that throws baseball with an initial speed of 160 feet per second. That's important. And it's at an angle of 28 horizontal with the ground. The ball leaves his hand height at 7 feet. And they are asking us a lot of questions here. We want to know the parametric equations that talk about the position of the ball as a function over time, both with how far did I travel horizontally and then how high the ball off the ground is at any given point in time. So we're looking at something like this, of course, but the x part of the equation is going to say, well, when t is some number, I'm x feet away from where our player threw the ball. And then the y part of it is going to say at any time t is 1 second, 2 seconds, 3 seconds, how far the ball is above the ground. And so x is for when I'm talking about horizontal, and the y is for when I'm looking for vertical. Now the expressions look very, very fancy, but they actually follow a very simple formula, and if you go into question help, they will pop it up for you, or of course you can Google it, and that's it. So all I need is the v naught, that initial speed, which was 160. I need the cosine of the angle that I threw it at. This is 28 degrees, so make sure that if you want to sketch this in the calculator, you either swap to degree mode or you put the little degree symbol on, t. And then my y, we're assuming that g is 32 feet per second, which is kind of the staple that we use a lot. And so because we tend not to measure things in meters in the States, I got a negative 16t squared plus a 160 sine of 28 degrees t, and then h is my starting height, so that's going to be a 7. And so I'm looking at A. Those are my two expressions. They look very fancy, but they're not that bad. That is the first part of this. B is how long is the ball in the air? So how long did it have to travel after I threw it? Basically, where does it hit the ground? At t equals what? Right, so this is t equals 0. When does this part hit the ground? Well, this has to do with height off the ground, just the y. So I don't need to work with the x part. All I need to do is work with the y part, which, quite frankly, is not such great news because I have these crazy looking numbers that I'm going to have to deal with. And they certainly cannot be factored. So when I set this equal to 0, I'm unfortunately going to have to work with the quadratic equation. Let's see if it wants us to, well, it wants us to round, so that's good news. At least we can plug this in at the end. We don't need to give it in radical form. Quadratic equation is x equals a negative b, so that's a negative 160 sine t, plus or minus the square root of b squared, goodness, 160 squared times sine squared of 28, minus 4 times a times c, all over 2 times a. So not pretty, but we have a calculator. I'm going to turn this mess on, and I'm going to go to mode so that I can change this to degree since I'm typing in 28 degrees. And I'm going to go out to the main screen, and I have a negative 160 sine of 28. I'm going to do the plus first. The square root of 160 squared times sine of 28, close that up, squared, minus 4 times 8 times c. I'm just going to go ahead and make that a plus. 4 times 16 times 7. And then I'm going to close my square root symbol. 2.92. Alright, so this is positive. So if I divide by a negative, that's not what I'm looking for, right? I didn't like throw the ball back in time. So I'm going to say second, enter, and I'm going to scoot up and change this to a minus. That's better because now when I divide by my negative 32, I know a negative divided by a negative is going to be a positive, and I get 4.8-ish seconds. That's how long we're in the air. So after they throw it, 4.8 seconds later, it hits the ground. Let's see where they want us to round to. 2 decimal places. So 4.79. Now I want to know, well, what's the max height? Well, the max height, again, has to do with the y. So now all I'm looking for is where is that peak? Where's that vertex? Now you can graph this in your calculator and find a max, but to find the max of a quadratic is actually pretty easy. We're looking at this again, but I'm just looking for the highest part. That's going to be x is going to be equal at a negative b over 2a. So negative 160 sine 28 divided by a negative 32. Negative 160 sine 28 divided by a negative 32. That's when it happens. I need to plug this number in to my y part. And then let's see, the easiest way to do this is to hit store and then hit the variable key. So now every time I type that in on the main screen, it will do the substitution for me. Watch. It's a pretty handy little tool. Make sure you close that trig function before you hit the t, or else it's going to find the sign of sine 28t instead of finding sine of 28 and then saying times t. That can be a sneaky one. 95.16 if they still want 2 decimal places. Maximum height. Oh, when does it happen? Oh, I did too much work. 2.35. Now they want to know what that is. 95/16. Total distance traveled. Okay, now we can finally get into that other part. So we know at 4.79, right? Let's scroll back up. So I plug it up. At 4.79, I'm on the ground. How far is that? So this is 4.79. What was this distance traveled here? Right? That's what we're looking for now. Well, that's the x part. Back to the calculator. 160 cosine of a 28. Let's go ahead and plug in the t that we know we need to find, which was a 4.79. 676.69. 676.69. So definitely a messy looking problem, but there. Now I think I have this plugged into my calculator, so when I hit graph, I kind of got something, but it didn't look that great. And let me see if I could do trace. If I get all the way, all right, so it stopped at 3.1. That's why I didn't hit the ground. So I'm going to go into here, and I'm going to hit, I still have my t maxed at pi. Let's make it 5. Oh, this might be a little bit easier. Slow, but easier. Now, I can find second calc, and I can find some values. I want to know when t is 2.34, right? You found part of it, but you don't want to actually plug it in. You can find the x and the y. Or you found 4.79. You can say second calc 4.79. It'll do a couple of substitutions for you. You don't have quite the same amount of options. Oh, I guess I hit the wrong button. You don't quite have the same amount of options that you do when you're in the function version. I apologize for the long video, but the last question was a long one, and that's how you'll get through your parametric equations.